10. The first chapter in your science is force, gravitational force, and there is one question for the verification of Newton's law of gravitation. To prove this relation also the question might be asked. First we must know what gravitational force is. It's the force that is produced between two heavenly bodies or any other celestial bodies in the universe. It's said to be gravitational force, and in order to calculate the gravitational force between two bodies, Sir Isaac Newton has proposed one relation. That law is said to be Newton's law of gravitation. So for the verification of Newton's law of gravitation, here is one verification. For deriving the relation of Newton's law of gravitation, we have considered mass A, body A of mass. We have considered the mass of body A as capital M and small m for the next body B, and the distance between the centers is denoted by letter D. We use this. Let us consider capital M mass of body A, small m mass of body B, D distance between the centers, and F is the gravitational force between two bodies A and B. Now, according to the law of gravitation, we must know the Newton's law of gravitation. Newton's law of gravitation states that the gravitational force produced between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So from this first statement, it is proportional to the product of their masses. Product of the mass we have considered one mass as capital M and another mass as capital small m. So F, since it is gravitational force, we derive this relation. Here we can write F is proportional to the product of their masses, means capital M into small m, keeping the distance constant here. And next statement, it is said that gravitational force produced between two bodies is inversely proportional to the square of the distance between their centers, and we have denoted this small letter d as the distance between their centers here. So F is inversely proportional to the distance here 1 by d square, keeping the masses constant here. So combining these two equations, we can write this F proportional to the product of two masses by d square. So F is equal to capital G m by d square, where we use this G as a proportionality constant, which is said to be gravitational constant, having the constant value 6.67 into 10 to the power minus 11 Newton meter square per kg square. And similarly, when we consider this capital M mass, if we take 1 kg, the value of mass, and another mass also 1 kg, and the distance between their centers 1 meter, then from this equation, keeping these values capital M, small m and d, we can write this F is equal to G. So from this relation we can define this capital G here as F is equal to G. We get F is equal to G. So in which case F is equal to G is when we take capital M is equal to 1 kg, small m is equal to 1 kg, and distance d is equal to 1 meter, then we can define this G, the universal gravitational constant, as the gravitational force between two bodies of 1 kg masses, and when they are kept at 1 meter distance apart. That is, universal gravitational constant is defined as the gravitational force produced between unit masses. We used 1 kg masses, so that can be said as unit masses kept at a distance of 1 meter apart. That is universal gravitational constant. So we can derive this relation in this way. View this video and try to derive the relation yourself also. Thank you.